Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on gravity and gravitational field from March 2021, Paper 4, Variant 2. I said this is a typical type of question because this type of questions are very common in past papers. In today's class, we are talking about March 2021, Paper 4, 2. Time for this exam is 2 hours and you need to answer all questions in this paper, and the total mark for this paper is 100. On the second page of your exam paper, you can find values of some common constants. And in paper 4, you will need some of them to do some calculations. So if you need value of any constant, you can come back to page 2 and you can find the value of constants. On third page of exam paper, some important formulae are also given. The first formula for A2 physics is about gravitational potential, very common one. Most of the time you will need this one for question number 1. And the next formula is from thermal physics, and the next two formulae, these are from simple harmonic motion, and the next one is from electric field, very common one. You need this one for some calculations. And next three formulae, these are from capacitance, very common one. You will also need for some calculation if there is any question about capacitor. And the next one is about Hall voltage, typical type of formula, and in many past papers you will see questions based on this formula. And next one is from alternating current from AC, very common one, and the next two formulae are from nuclear physics. So you will need them for some calculations most of the time in your exam. So let me highlight this formula. It's very important one. Let me explain you this one a little bit. Here, for example, the x you can replace with n with number of nuclei. So this you can write down. This will be equal to n naught times e to the power of negative lambda t. X you can also replace with activity. So we can also say activity at any given time. This will be equal to initial activity times e to the power of negative lambda t. So mean x you can replace with n, or you can replace x with a. For part A, question is asking us to state Newton's law of gravitation. And this question has 2 marks. And this is a typical type of question. It simply means that almost every year they will ask you to state Newton's law of gravitation. So let's try to understand what exactly Newton's law of gravitation is. Imagine that we have one mass, this is m1, and we have another mass, let's say this is m2. And the distance between centers of these two masses, let's say the distance is equal to d. So Newton's law of gravitation simply tells us the force of attraction between these two masses is directly proportional to the product of these masses. And the force of attraction, or you can say the gravitational force, this is inversely proportional to the square of separation, or simply you can say square of distance between these masses. We can say this is 1 and this is 2. Now if we combine 1 and 2, we can also write down F is directly proportional to m1 times m2 divided by d square, means inversely proportional to d square. We can also write down this one in equation form. We can write down F is equal to capital G m1 m2 divided by d square, and g is the universal gravitational constant and its value is 6.67 times 10 to negative 11 Newton meter square per kg square. You can see this value is very, very small. So force of attraction is significant for heavy masses. That's the reason you don't feel force of attraction between you and your friends or your neighbor. So this is significant for heavy masses. Now let's try to write down the answer for this. In order to answer this question has 2 marks, so you have to mention these 2 points. So this can be point 1 and this can be second point. This is how you can write down your answer. If you have mentioned in your answer gravitational force between 2 point masses, later I will explain you this one why we need to say 2 point masses, mean point masses. is directly proportional to the product of the masses, you will get 1 mark, and that will be B mark. And the second mark you will get if you have mentioned inversely proportional to the square of the separation. So this is second B mark. So this is how you will get 2 marks. The second point we need to understand about gravitational force is that the force between two masses, it does not depend on medium. So simply I will say the force does not depend on medium. Does not depend on medium, or simply you can say the force is independent of medium. So in this case I'm writing it does not depend on medium. So very important point. So it simply means that if we have two masses, let's say we have these two masses, they are in the air. So there is a force between them. Now, if we take and we place these two masses inside water, so the force of attraction between them will be the same if we keep the distance between these two masses same. So that's the reason the force of attraction between these two objects is independent of medium. And the next thing we also need to understand is that the force F1 means the force on 1 by 2 we can write down in vector form. This will be equal to the force on 2 by 1 but in opposite direction. So negative sign is telling you that this is in opposite direction. So this is also very important point we need to understand. Newton's law of gravitation, this is only valid for point masses. So this is only valid for point masses. So the size of the object has to be very small. So this is only valid for point masses. So the point masses simply means that one thing you can say the size of object is very small. So you can say size of object is very small. So this is one thing is telling you point masses. Size of object is very small. So we can treat as a point mass. You can also treat an object means two objects as a point masses if the distance between the masses is much greater than the size of the objects. For example, we calculate the force of attraction between sun and our planet. So this is our planet Earth. So the distance between these two is much greater than the size of them. So we can treat them as a point masses. So that's the reason we use here point masses. Sometimes this question has 3 marks and 1 mark only will be for point masses. If you will mention point masses, you will get the 3rd mark, otherwise you will not get. So when you define Newton's law of gravitation, you have to be clear. It is the gravitational force between two masses that is directly proportional to the product of masses and inversely proportional to the square of distance between them. I hope it is now very clear to you. Let's move on to next part. For part B, the graph between t square and r cube is given to us, and we will be using this graph to answer part B. So let's move on to next page and try to answer next question. For part B, question is asking us to determine the mass capital M. Means question is asking us to calculate capital M. But the graph between t square and r cube is given. And this graph is a straight line. So simply we can compare this one with straight line equation. We can simply say y is equal to mx plus c. But c in this case is equal to 0 because this is passing through origin. So there is no y-intercept. Now if we compare here, so this is over y and this one is over x, and the gradient means the m from here will be equal to 4 pi squared divided by gravitational constant times capital M. But we need to calculate M. So simply we can rearrange, we can write down 4 pi squared divided by g times the gradient, means the gradient of the graph. That's all what we need to do. Simply we can calculate the gradient of this line and we can plug in here and we can calculate value of mass. I have done this calculation already, so let me show you how I have done. So if you look at this one, first of all, I have taken these 2 points, mean this point and this point. I have calculated gradient of the graph and this is our answer. Now I have plug in values of the gradient. So this is value of the gradient, but you can see this one, this is in years. So I have converted year into seconds. So this is 365 days. One day has 24 hours and 1 hour has 3600 seconds. And this is our final answer. For part C, question is telling us that a rock of mass small m is also in orbit around a star in B. The radius of the orbit is r. Explain why the gravitational potential energy of the rock is negative. This is very common question. So simply we can understand. Imagine that we have star here. So this one is the star. So this is a big object, heavy object. And let's say in this orbit, the rock means is orbiting. So this one is the rock. So simply we can imagine that this one is the rock. Now we need to understand is that if we go to the infinity, very far away from the star, at this point we take gravitational potential energy at infinity. This is equal to 0. And anywhere between the star and the infinity, gravitational potential energy, I'm writing this in GPE, this is taken as negative. Why this is negative? Because here potential energy is the maximum. So anywhere between the star and infinity, gravitational potential energy is less than gravitational potential energy at infinity. So that's the reason this is taken as negative. Another way to understand this one is, let's say we have this is ground. If we raise this mass, for example, we place this mass on the ground. If we raise this one, the gravitational potential energy of this object will increase. Now imagine that we raise this object to this point and now we lower this one, means we bring this one down. So the gravitational potential energy of this one will decrease. But in this case, we are assuming that the maximum gravitational potential energy means is at infinity, and that we are taken is equal to 0. So between the star and the infinity, gravitational potential energy has to be lower than GPE at infinity. So the only possibility, it has to be negative. And other way to understand this one is that if you take any object away, I mean if we take this rock away from the star, the gravitational potential energy will go on increasing. As simply in this case, if we raise this object, so the gravitational potential energy of this object will increase. And other way to understand this one is that when you raise this one, we do work against gravity, and that work done becomes GPE of the object. But if we lower this one, the work is done by gravity. So the energy got out of the system. So the gravitational potential energy of this object decreases. So simply what I'm saying is that if we move this object this way, the GPE of this rock will decrease. So simply we can say GPE will decrease. But if we move this rock away from the star, GPE, gravitational potential energy of this rock will increase, because if we move away, we will do work against gravity, and that becomes the GPE of this object. But if we move this way, in this way work done is done by gravity. So it means energy got out of the system, so the GPE of this rock will decrease, and that will be more and more negative. So let's try to write down our answer now. I hope you got some idea. Now let's try to write down our answer. So this is how you can write down your answer. The first point you have to mention is that GPE is, or simply you can say gravitational potential is defined as 0 at infinity. And GPE is also 0 at infinity. Since gravity is always an attractive force, object in a gravitational field will always be attracted inwards. Hence, work is done by gravity, work got out, causing rock to lose GPE. So when it is pulled from infinity, means if we pull object this way, work is done by gravity and GPE will decrease. So gravitational potential energy of the rock is always negative because the maximum is 0 and the lower than that one is negative. So between star and infinity, GPE is always negative. This question has 3 marks. If you have mentioned that gravitational potential energy is defined as 0 at infinity, you will get 1 mark, and this is B mark. And the second B mark you will get, if you have mentioned gravity is always an attractive force, you will get the second B mark, so this is second B mark. And the third mark you will get, if you have written work is done by gravity, work got out causing rock to lose GPE, so you will get the third B mark. So this is how marks will be awarded. Now let's move on to next part. The second part, C2, is asking us, show that the kinetic energy of the rock is given by Ek is equal to capital G, capital M, small m over 2r. So in this case, this is our star and the mass of the star is capital M. So simply we can say this is mass of the star and the rock is here orbiting around the star and the mass of the rock is M. Now we need to show that kinetic energy of the rock is given by this. I have already done so. Let me look at my answer and explain you with the help of my answer. Now you can see in this case I have written already gravitational force provides the centripetal force, meaning this rock is orbiting around the star, so there is centripetal force acting on this and that centripetal force is due to gravity. So this is a very good point if you write down here. Now in this case what we have done next, gravitational force is providing the centripetal force, so this is our gravitational force and this one is the centripetal force. So R we can cancel on both sides because this is common and then we got this one here. So you can see G capital M small m over 2R. So we have divided by 2 on both sides. So this is 2 here and this is 2 here. And this is kinetic energy now. Ek, this is equal to capital G capital M small m divided by 2. This question has 2 marks. The first mark is M mark. You will get this first mark M mark if you have equated these two forces. And the second mark is the answer mark. You will get this answer mark if you got the right answer. So this mark is very important. If you simply write down this one, of course, you will not get any mark. So you have to show the process, means you have to show your working to get 2 marks. For the last part, question is asking us to use the expression in second part to derive an expression for the total energy of the rock. First of all, let's try to understand what is total energy of the rock. So this is our star. So simply you can imagine that this one is the star and the mass of this one is capital M. And the rock is here, its mass is M, and this rock is orbiting around this star. So it is orbiting around this star like this. Now this rock, it has 2 kinds of energy. The one is the kinetic energy because it has speed, it is orbiting around this one. And the second energy of this one is GPE, gravitational potential energy, that is due to its position around the star. So it has 2 kinds of energies, kinetic and GPE, gravitational potential energy. Now the total energy, simply we can say that in this case E total means the total energy of this rock is simply equal to gravitational potential energy plus the kinetic energy of the rock. Now simply we have to add these two together. Gravitational potential energy of the rock, this is capital G, capital M, small m divided by R. And R is the distance from the center of the star to the center of this mass. And kinetic energy we have already calculated. That was G, capital M, small m divided by 2R. Now we simply have to simplify this one. In this case, we can take LCM. LCM is 2R. So this one has to be multiplied by 2 because if you divide this one by R, you will get 2. So this is 2 capital G, capital M, small m, plus we have G, capital M, and small m. So our final answer in this case is capital G, capital M, small m divided by 2R. So this is total energy of the rock. Now, maybe some students are not clear why we're using negative sign here, because the rock is here, it is between star and infinity. At infinity, we have already discussed GPE is equal to 0. So that's the reason we have to use negative sign here. So this is very important one. You have to use negative sign here. So our final answer for this one is this. So this is total energy of the rock. This question has 2 marks. The first mark you will get if you have written total energy is equal to EP plus EK, means is equal to GPE and kinetic energy. You will get first mark, and this is C mark. And the second mark is the answer mark. If you got the right answer, you will get second mark. This is how marks will be awarded for this part.